So this is a test-driven approach to documenting RESTful APIs with Groovy and Spring REST docs. I'm Jen Strater, also known as Code Generator on Twitter. Yeah, thought that was pretty cute. So if you go to my Twitter account, you should see that all the slides for this have been posted. It goes out automatically a few minutes before the presentation. And so you can follow along if you want, or look at them later when you get home. All of the links you can click on if you actually download the slides. So here I also have 3 examples that I'm going to go through, and you can take a look at those later. So a little bit about me. The introduction video said that I am at the Technical University of Denmark. You may notice from my accent, though, that I am originally American. I am currently on a 1-year program, which is an exchange between the United States and various countries throughout the world called Fulbright. And so that grant program has been funding my research on the Groovy compiler and static analysis and some programming languages things at the university. And I've been taking some classes too. Okay, but before all of that, I was actually a senior engineer for a consulting company out of Minneapolis, Minnesota. It's called Object Partners, and the work that I did for them is what this talk is about. I do lots of other things too. I am also a co-founder of an organization called Great Ladies, and we encourage women to join and stay in the Groovy community, and I also teach some workshops and do other things related to that. At the end of my Fulbright grant, I am staying in Europe. I'm going to take a job at a really awesome startup called ZenJob in Berlin. And then I'll get to use some of this stuff again. So that is quite a lot about me. I'd like to also kind of, by show of hands, get an idea of who all of you are as well. I assume that if you are in here, you have some kind of an idea of how to create a RESTful API. And I know that this is a more general conference, so it might not necessarily be in the same frameworks, but the technologies and the tools and the pipeline are all going to be very similar. So first, who is familiar with Groovy as a language? Okay, a handful. And then who has used Spring Boot, either Java or Groovy? Okay, some more hands. Based in the group, I'm guessing, actually, is there anyone who has used Ratpack or is familiar with it? Okay, so I'll spend a little bit more time explaining what that is then. And for the Groovy folks, are you guys using Grails? Phew, okay, awesome. So we'll get to that one at the end, and I'll explain a little bit more about what's going on for everyone else. Now, the next thing to talk about is what kind of documentation you're using right now. So there are 2 kind of ways, and this is definitely not a comprehensive or entire list of all the things that you can use for documentation, but these are 2 different styles that I'm going to kind of compare. So the first one is Swagger. So who has used Swagger in any? Okay. And who is familiar with ASCII Doc / ASCII Doctor as a documentation tool? Okay, so I'll definitely go over a little more on that. Okay. So now that you know a little bit about me and I know a little bit about you, I feel pretty confident that I can share my secret with you. And that's that I hate writing documentation. And I put an asterisk here because it's not the actual documentation that I don't like writing. Having really good documentation is very important. But the things that I don't like are having to write things out over and over again. One of the reasons why I like these frameworks and the Groovy as a language is that it reduces a lot of the boilerplate and a lot of the things that we have to write over and over again. So when I was tasked in the fall of 2015 with, so I was consulting for a company at the time, and they put me on this project to write, or to centralize and kind of bring together all of their API documentation. And I was not really thrilled with the idea of writing all of this out by hand. I thought, I'm a programmer, surely there has to be a way that I can code this. So there were a few things that we investigated, and before I talk about the tools, I wanted to kind of talk about the process for how we got the documentation together, and some different things that we noticed. So the first thing that was very important was where our APIs kind of fell in this REST maturity model. And so if you aren't familiar with the REST maturity model that is in the graphic, it's from a blog post by Martin Fowler. The text for that is definitely too small, but you can see it if you download the slides. And for the most part, it's a really good way of characterizing different features that APIs have, how many of the different criteria it fulfills to make it a RESTful API. So things like whether or not your API uses proper resource names, whether you're following the HTTP standards when it comes to verbs and status codes, and then the last criteria of whether or not your API actually uses hypermedia. So when we kind of looked at the different APIs that were in our organization, we noticed that most of them are not actually RESTful. They usually fall somewhere in this, between a level 1 and a level 2. So we're using kind of the right namespacing, but we weren't really consistent about the way that we were handling the HTTP specification. But we knew that when we started looking at a documentation tool, that we wanted to get better about some of the code quality and code standards that we were using. And so we needed a documentation tool that was going to be flexible enough to let us do hypermedia and the other things that we wanted to do in the future. In particular, this was important because I know that there's some debate now with the new versions of Swagger, but at the time, Swagger didn't support hypermedia, which is, I think it's now the API specification. Anyway, so that was kind of a deal breaker if we wanted to do hypermedia. The next thing that came up was this wonderful graphic that I took from a friend in the Groovy community. And of course, as most things, it started out as this huge monolith that we were splitting into smaller microservices. And this is kind of important when you talk about documentation, because when it's a monolith, it's really easy. You have everything kind of in the same place. But when you split up your architecture into lots of microservices, you can either document on each individual service, or you can create one document for all of the different services and how they work together. So we wanted something that kind of looked the same over all of the services, and also something that showed how they work together. And, okay, so the next thing that came up is how do we document central information? So things that we only want to do once, like we only want to say how the security is implemented and you use a token or whatever security you're implementing. And so this is something that a lot of different tools support. You write it once and it's in kind of a main section of your document. The kind of last thing that came up, and definitely a more minor thing, was the way that the documents actually looked. So there's two major styles to API documentation. The first one on the left is what Swagger UI uses, and so it lists these all out by path, and that works okay if you know exactly what you're looking for and you can kind of pinpoint it. There are some other things that I'm going to talk about why this particular implementation is nice. But there was one problem that our CTO didn't really know how we had named our resources. So he was much more a fan of this resource-based design, where you kind of have some key topics, and then you can go into individual sections and document them in the same way. Okay, so I've been talking a little bit about this tool called Swagger. So Swagger is great for documentation, but it's very, very important that you know that Swagger is not just documentation. It is an entire API standard and specification that you can use for lots of different things. So maybe you're already using this for some of its other features, like creating client libraries or integrating with some monitoring tools or testing. So what I want to focus on, and what I'm going to focus on mostly, are the documentation aspects of it, and whether or not you choose to use Swagger for maybe part of it, or use Spring REST docs. That's totally okay. So within this ecosystem of Groovy and Java, in Spring in particular, there are two different approaches to adding Swagger. And so the first one is Spring Fox. And Spring Fox is a great library that is super simple. You add some annotations to your code, and it generates your Swagger specification, and it also generates the UI for you if you choose to do that. So like I said, so there's two dependencies here, one for if you want that specification, the other if you want the UI, and you don't have to use them together. The other option, if you're having trouble with Spring Fox, or if you aren't using Spring, is that you can always create your own custom specification, either in another ecosystem that may have a library for it, or you can maintain it yourself too. So you can create this JSON file and describe the different aspects of your API. It's really great because you have complete control over it. But then you also have to maintain it too. And that was really the problem for us, is because you get into a lot of overhead, and if you're trying to fix something really quick, you may patch your bug but not update your documentation, and then you get into some problems there. So then once you've added your specification, you can choose to use the Swagger UI or something different. So Spring Fox has a version, or you can also maintain one yourself. Just download the library. It's just a bunch of HTML, CSS, and I think some JavaScript files. And you can customize it a lot that way too. Okay, so as we started to look through this tool, there were some things that came up that in our specific use case didn't work. So the first one is that we were having issues with our security implementation and the standard UI, and that we had to keep writing around the framework. And the more that we did this, the more frustrated we became. The next thing that ended up is that this is very annotation-based. So you end up with a lot of annotations just for documentation. And it doesn't seem like this is a lot. I had to find an example that would fit on the slides. But if you imagine this gets duplicated over all of the controllers, over every endpoint, that can get kind of big. And then the other part is that this is all written out manually. There's no guarantee that this is actually correct. So if we take out just the ones for documentation, you can see that the example becomes much shorter. So that code is actually code that I pulled from our environment and renamed everything so that it would be safe, or safe to share. And like I said, imagine that is throughout your entire code base. So by moving your annotations into another format, it can make your original source code a lot easier to read. We were also having some trouble with the way that we had kind of modeled our data. And Spring Fox and the Swagger specification that way are really good for simple examples, but as our project got more complex, we were spending a lot of time writing out things manually anyway. But there is one really big advantage that we miss from the Swagger UI, and that is the try it button. So our QA team in particular really liked having a way to test each endpoint. So the way that this works is that you have an example of kind of what request looks like, response looks like. In that white box, you would add, you can have that generate some sample test data for you, or you can manipulate it and kind of run it as a form, which was really nice in simple cases again. But then it also kind of led to this laziness too, because we would just manually test it and not write actual good unit and integration tests. But there are alternatives that can help you get some of the same functionality using different tools. The first one, of course, is through Postman. So Postman has a feature called Collections, where you can save a bunch of requests and responses and kind of some sample data, and then you can share that using its configuration file. If you're running a public API, they even have an option now called the Run button, which will let you integrate a widget onto your page. You click the button, like the one in the top right, and it will start up Postman, and you can run through a test series that way. I'm a little bit old-fashioned, so I still use curl for some of this stuff. And because we get a tool like Spring RESTdocs that generates all the curl statements, I don't have to think about what flags to set. I really just copy and paste it from the documentation, maybe make a couple tweaks, but I can run it straight from my command line. Okay. So if you do like some of the things with Swagger, or you're already using it, you don't have to give that up, like I said. You can even use a couple libraries to make it easier to work together. So the first one is called Swagger to Markup. So if you don't particularly like the Swagger UI, you can use this library to convert your Swagger specification into either an ASCII doc or a markdown format. So that kind of looks like this, a lot more along the lines of what we were looking for in the end. You still get some path things here, but a lot of this is configurable. The next library that you may want to use is assert JSwagger. So I've kind of talked about how documentation can be generated from your source code, which is what you implemented or what you intended to implement. So assert JSwagger is a contract-first approach that you can write out your contract and then verify that your contract matches the Swagger specification. Now that doesn't mean that the contract matches what you implemented or the Swagger specification. So by using these together, you can hopefully cover your whole pipeline. Okay. So I talked a little bit about how you kind of use these things together. And a lot of this has to do with testing. So you can use this approach that I'm calling test-driven documentation. So test-driven documentation is my it has to be better, right, solution. And so we start with our original red-green refactor cycle. And we're adding in this step for documentation. So that means you start with your failing test. In order to go to green, you have to update your or add documentation. When you refactor, you start the cycle again. And when you're refactoring, you're also updating your documentation. So it makes sure that at least that part of it stays in sync. And so we really found this to be a really good solution, a winning solution, because it ensured that our documentation matched what we were actually implementing. We also started writing more tests, and that was probably the most surprising thing that happened, is that in order to get the documentation, we started writing more tests to actually get that functionality, and we found some bugs that we wouldn't have otherwise. It also reduced a lot of the duplication. So maybe if we already had some tests, we were writing the documentation through annotation in the source code and writing tests, and we can kind of couple those together. So the solution for test-driven documentation that we looked at in our ecosystem was Spring REST docs. Right now, it's the only implementation of this that I know of, and I think it does it really well. The thing that really changed the game for us are that it generates these snippets, the curl statements, and in other examples. It also ensured that our tests started failing when the tests failed when the documentation is out of date. It's also useful in a couple of cases in our ecosystem, in the Groovy ecosystem, where you cannot use Swagger. In particular, Ratpack. So there wasn't anyone who was familiar with Ratpack, but Ratpack has a very special and unique way of handling routing. That means that you can't just look at the source code and tell, we as humans can, but can't programmatically iterate through the mappings and tell what all of the possible endpoints are going to be. It's handled dynamically and programmatically in a way that an annotation is not going to help. So Spring REST docs is a really good approach for that. Of course, I've gone through a little bit about the journey to getting here, so I wanted to also show an example of how you get started. So as an overview, it's an official Pivotal project, so it's very well supported, has some core team members on it, including Andy Wilkinson, who is the project lead for this project, and also a Spring Boot contributor and lots of other wonderful things. And it was a little bit rushing to do this. Just on Monday, they released a new version. So now there's a new Twitter account. The Twitter account and the logo are new as of Monday. And there have been one major release, so it's 1.2 now. And there's a bug fix in 1.1.3. Okay. So if you are not in the Groovy ecosystem, there are some other talks that you might enjoy as well. So the first one is, of course, from the project lead. It's a little bit older now. It's from 2015, but I still think it's a really great talk because he goes through a lot of the internals of how it works and why he made a lot of the decisions that he made, and it's a really great talk. Another one that's more recent is from last year. Anders Evers gave a talk at the Spring One platform in the US, and it goes through an example using Java, and particularly hypermedia. The last one is that I noticed recently that there is now a new developer. I think he's from Warsaw. There's a talk, I of course haven't seen it because it's in Polish, from the Warsaw JOG that goes into an example, again, using Java in a hypermedia. So you should check that one out too. Okay. Then, yeah, so we're now on 1.2, and there's enough to see some changes from release to release. In the first one, it was really exciting to get out of the door. The first testing framework was mock MVC, which is very specific to Spring itself. Then we got auto-generated snippets from the beginning. There's also some ASCII doctor integration, which was very important to get this into a way that we could generate our documentation along with the build pipeline and program it that way. It was also very important from the beginning to have hypermedia support. The release that I was most excited about as a Groovy programmer was 1.1. And this is because it added a new testing framework called Rest Assured, which expanded it outside of just the Spring universe, and now you can use it on a lot of other projects. It's also, there's also some other things that happened to make it easier with relaxed and reusable snippets. And some more testing frameworks if you're using TestNG, or if you really like Markdown instead of ASCII doc. So like I said, just on Monday, this new version came out, and it was kind of a little bit in between. So 1.1 came out, or the most recent bug fix came out in August. Then this 1.2 release just came out, and but there are some really big things in it. So it starts pulling in ASCII doctor macros, which reduce even more boilerplate, and gives us some more types of responses, more examples that we can use, as well as now supports more complex payloads. So what I mean by that is if you have a JSON structure that's really, really nested, a table is not going to be the best solution because you can't very easily describe 3 or 4 levels deep using a table. So in that case, it might be more useful to show what the actual response is going to look like. With the release to 1.2, it was also announced that they're now going to start working on the roadmap for 2.0, which will increase some versions of things. It's going to go to Spring, I think Spring Boot 5, Java 8, as well as supporting a major player in that field, the web test client. Okay. So what I wanted to bring to this in particular is how do we build on this and bring this into the Groovy ecosystem? And that's through Spring Boot, Ratpack, and Grails. So to start, we have all of these different pieces that we use Gradle for to create a fabulous document. So let's start with Spring Boot and Groovy. So I have an example project on GitHub that is one of the ones in the notes, and it's still using version 1.4. I haven't upgraded it to 1.5 yet. And then I'm using Gradle, of course, because this is the Groovy ecosystem, Spock for testing. Since this was the original version, it shows mock MVC as the testing framework. And then there are 2 different approaches for publishing your documentation. And I'll go into a little bit more detail on those. So to create my Spring Boot app, I started with the lazybones template. And over time, that's kind of changed because I've done version upgrades, but originally started with the lazybones template, added just a few endpoints, and then created the example. So of course, if you're in a true TDD or test-driven environment, then and you're starting your project from scratch, then you start with your tests first. But if you, like us, already had some examples and some endpoints running, and then you added Spring REST docs, you probably have some kind of controllers and some setup already. If you aren't familiar with Spring Boot, these are just 3 basic endpoints. So the first one describes a resource called greetings, which you can either get the entire list or you can search through it by its message. You can get a message by its ID, or you can create new greetings. Okay. So now we have kind of a base to work on. We have an application. Now we can talk about how AsciiDoc kind of fits in with using Gradle to create the documentation. So you do this through a Gradle plugin called the AsciiDoctor Gradle plugin. And okay, so there wasn't any familiarity with AsciiDoc and AsciiDoctor. So AsciiDoc is a format for writing documents of any kind. So this is kind of an example from a different API. It's it should be pretty human readable. It's got some little symbols that end up converting into formatting, but it makes it a lot easier to write than having to work inside some other frameworks. You install it pretty easily with Gradle. There's a few things to add and some configuration, and you're up and running. So then if you actually run your Gradle build, you can get a wonderfully formatted document. So this is the HTML page that corresponded to that AsciiDoc with a little bit more information that wasn't on the screen. And so AsciiDoc and AsciiDoctor are not just about converting these files into HTML. It's good because it's universal for lots of other formats too. So you can use it to create PDFs and even use it to write books. You can export it to lots of different formats from one single AsciiDoc file. Okay. So at this point, we have our application. We have some sample documentation. It doesn't have any test-driven stuff in it. So let's add the tests. Okay. So we're going to do that through Spring mock MVC. And mock MVC is a mock, so it doesn't run your entire application. It kind of mocks out part of it, and then you can test your endpoints accordingly. And when we start looking at this, you may think, oh, this looks really similar. Grails is built on top of Spring, but this actually doesn't work for Grails, and we'll have to use Rest Assured for that. Okay. So the first way to set up is using the standalone version, and that just takes it for a simple controller. Once our project got a little bit more complex, we weren't using this anymore because we wanted the entire context. We wanted our security. We wanted all of the different parts of each path. So we use this instead. And hopefully, if you're using Spock 2, I can save you some time by saying that you need to remember to include the right version. So this is all Spock Spring, and so it needs a different version rather than just the regular Spock core. Okay. So now we have our basic app, we have some tests, we have some documentation. How do we bring it all together with Spring REST docs? And this was the image for Spring REST docs. So we need to update our Gradle file again to add the dependency, of course. And one thing that came up and was very important this morning is that if you are using Spring Boot in particular, you need to remember to enforce the particular version. So Spring Boot includes a version of Spring REST docs now by default, and I'll explain that a little bit. But if you want to use a different version, remember to override it. Okay. We also need to kind of tell AsciiDoctor where to find these things that we're generating so that it can include them in our documents. With the new version that came out on Monday, there is now this AsciiDoctor module, which you can reduce this down even further. So you add, and it's not a compile dependency. It's really important that it's the ASCII doctor there. And by adding that module, you can reduce a lot of the things that were in that big configuration. A lot of those are defaults, and a plugin can handle that. Okay. The next thing is to actually wire this up. So we want to create this REST documentation object. And by default, it's going to go to a folder in your build. So if you're using Maven, it goes to the default there. If it's Gradle, it's going to build/generated snippets. You can also customize this, but one of the nice things that was just added is that it has that default now, so I don't have to duplicate it in every place. So we've got this thing that's going to hook in, and it's going to hook into mock MVC and set up a point where it can read what the requests are and it can read the responses. Okay. And so some of the rest of this is generic. It's going to change based on your testing framework. But here's the important part. So you get this document, and you start with what the fields are going to look like. So, of course, I've started using the reusable things because you don't want to have to write that section out in every test. You can share it across different tests in the same suite. Okay. So the first thing there is, so you're telling it, so greetings get example is the folder. So all of the examples from one endpoint go into a specific location. You can pre-process, post-process, you can do all kinds of things to these examples. And then the interesting part is in this response fields or request fields. And it's going to verify that the field names match, that the types match, that you're not getting too many or not enough of any request and response object. Okay, so this is still a little bit tedious, and if you're in the very special use case that you're using Spring Boot with mock MVC, you can actually reduce a lot of this down to just a single annotation. And I've been harping on that annotations are bad, but this is just one that reduces a lot more in the end. So the things in plus there are what you add. The comments are all of the things that you can now remove. And again, multiplied across an entire project, this can be bigger. Okay, so by default, this annotation is included in Spring Boot 1.4 and above. At this point, I think we're at 1.5, so it's been included in a few versions. But this is where we were getting the Gradle conflicts, because the version of Spring Boot is usually one behind the release that just came out. So until those get synced up again, remember your config. And it's true of Maven too. There's a spot in the documentation that shows you how to override the version. Okay. So now at this point, we have our Spring REST docs. We can build with Gradle and run the tests. And when we run just the tests themselves, it'll generate some snippets. Okay. And so the snippets that we get are, and there's a lot of them now, depending on your preference of input and output. So the ones in the left column here are things that you get by default. So it generates the curl request that you would need to run to replicate it. You get request, HTTP if you really like that format, as well as these new ones that came in the new release. The ones on the right are optional. So if you, depending on what kind of request you're trying to document, you may or may not have response fields or request fields or parts or paths or any of the other things that are kind of specific. So what I mean by this, sorry, it's a little early too. Yeah. So what I mean by this is that you get an ASCII doc that looks like this for an example response. And that, or in the case of fields, it takes this ASCII doc and creates places in the HTML that we can see and have formatted a little better. So the first one is curl request and then the HTTP response. You get some pretty colors and other things. So part of this is the ASCII doctor defaults of how to arrange things. Part of it is part of the Spring REST docs templates too. For example, in our production app, we created a custom table for these response fields that added a new column for whether or not it was optional. So you can definitely configure all of this too, and then use it in your own projects. Okay, so we have one example of an endpoint. The next one is creating a new greeting. So there's some slightly different things here. Of course, you have this content, probably is JSON or XML, that you want to document what that structure is supposed to look like. So since it's a post, you now have no response, but you do have requests. And so that's kind of the difference here to notice is it's now request fields instead of responses. And the screen went blank. Is it me?
Yeah. There's nothing.
Yeah. Lovely. It's not on the other side. Okay, sorry about that. Okay, so the next one is a list. If you want to specify some inner fields, there's another way to do this. Hopefully it's not a cable. Okay, so we're going to keep going. Important thing to note there is those square brackets. It's easy to miss, but if you're looking for how to do something embedded, use square brackets. Similarly, path parameters work the same way. So now that we have kind of requests and responses and all of these different things that you can add together, it's important to note that the order matters. So pre-processing, post-processing, request fields, then response fields, and the documentation goes through that. Okay, so once you get some tests set up, you'll probably try to run them through Gradle. And at first, we should get some failing tests. And the part I really like about Spring REST docs is this integration with the testing frameworks. So we get pretty detailed information about exactly which fields are present or not present, as well as information about whether they're not the types match. In JSON, that's not as big a deal because you only have a few different types, but with XML, that's much bigger. Okay. So now we have our application, we have some tests. The last thing that we need to do is hook Spring REST docs in with our existing documentation so that we can use Gradle to run it and make our docs. So there are two different ways to do this. The original way is to manually add in each part. So we have include from our directory of generated code the specific example that we want. The next option, now that we have this macro, is that we can reduce a lot of the manual steps and just indicate which endpoints we want, and it'll generate ASCII doc that matches that. Okay. So if we, at this point, run our entire build, we should get some docs from our source into an HTML format. And so there are some different strategies to how you might do this. In this case, I've been using the example that you include your documentation in your assets directory so that it builds and deploys with your application, which of course works great if everything is in the same place. But if it's not, there are some different strategies to do that, including publishing them to a different location. So if you look through my Gradle file, or in the Gradle files and the examples, you'll see that the hooks are integrating it all into a single build task. Then you can also run it separately if you want to manage that yourself. So you can publish the docs to GitHub pages, and it's really just another Gradle config. But remember, if you do it this way, that you're now managing that your documentation deploys at the same time as I have background music now. Wasn't expecting a. Okay. Yeah. So we've now published our documentation where you can either publish it with the application or separately to GitHub pages. So we take all of these working pieces and get to our final end result. There is, of course, support for different testing frameworks as well, which support Ratpack and Grails. Most of it runs through the same way. There's an example as part of the Ratpack project. Okay. So first you do a little bit different things with the ASCII doc, or the ASCII doc configuration. Make sure that you're using the right version of, so the first one is to make sure you're using the right version of Spring REST docs, because it is separated out into mock MVC and rest assured. A little bit of things about how Gradle works in general. Okay, so Ratpack works a little differently. And so this is an example of a handler in Ratpack. And it probably looks pretty confusing. You get all of these DSL-like features. It really looks pretty similar. So you're getting a book, you're getting all the books, you're creating a new book. We can run ASCII doc, use the plugin, and do the same thing. The difference here is in rest assured. So rest assured is a very different style of testing. So whereas mock MVC was just mocking out your application and you're kind of running against this test environment, rest assured actually you spin up your application and then actually test against it. And so that kind of affects the way that we hook in our documentation tool to read those requests and responses. In particular, the differences in syntax. There's some other things in that pull request that are more Ratpack specific, mostly about cleaning up and setting the data. The things that are different here are highlighted. So we're using filters, which is just rest assured specific, and we're now processing the request a little more. Because we're actually running against an application, we're going to get localhost for the default URL, so we can overwrite that host after it's been run, just to modify the examples. Okay, the rest is pretty similar. Okay, response. So yeah, now we get some different response types. If we run this all again with Gradle, we get a wonderful document. So now I was mentioning that rest assured works very differently in that you run the whole thing. You can also utilize this to document APIs that you don't have control over. So you can do this for public APIs. So I wrote a blog post that goes into a little bit more detail, but it mostly boils down to this one line, that you can use a separate test suite to run against anything you want. I ran this against just a JSON placeholder API that was public and created examples. So you may think, like, why do I want to use this? But if you don't have control over, maybe it's in another department or another division and you want documentation for it or to run some tests against it, you can do that. Or you can document something that lives on another machine and then have all of your documents aggregate to a central place. Okay. So I didn't get to the Grails example, but it's really pretty similar. It's included in the samples directory of the entire Spring REST Docs project. You go through pretty much the same way. The difference is that there's a many-to-many relationship here, and that gets documented a little bit differently. And there's some Grails-specific things. Okay, so this was the last part, that you can document this many-to-many relationship using a different type called subsection with path that essentially, so you don't have to document or test every subpart of these tags. You say it once and it's done. And then it does a little bit different request output there, that it's an array instead of all of the sub-elements. And when you run that, you get another lovely document. So this was a project that we started a long time ago. I've since left that team, but I do stay in contact with them. They made it to production. They're still very happy with Spring REST Docs, particularly when they can just hand it off to another team and say, read the docs. Okay. There's a lot of information that I haven't even started to cover with how to do security, constraints. I didn't touch hypermedia or XML, but you can read about that. It's a documentation tool. The documentation is wonderful. Okay. So in conclusion, we found that API documentation is complex. You should pick the tool that's right, whether that's Swagger or Spring REST Docs. It depends on your use case. But for us, Spring REST Docs was very promising because it enforced good testing practices and documentation practices without adding anything extra to our source code. And of course, I still don't like writing boilerplate documentation, but at least it's a little bit less painful, and I can write some code too. If you'd like to learn more, you can join the Groovy community Slack to talk about Groovy things. Spring REST Docs has its own specific Gitter, and you can see more of me in Copenhagen at a conference in June or May/June. So I know that's a lot to throw at you all at once. You are, of course, welcome to download the slides, go through them. You can ping me on Twitter. I'll be around for the next few hours for this conference.